Hi guys, I'm Joshua Meyer, an Associate Security Analyst at ISE, and I'm a researcher here at ISE Labs. We're a group of researchers here at ISE that are looking into IoT and embedded devices and seeing what we can find. Today we're going to be taking a look at a network-attached storage device, the TerraMaster F2 420. So network-attached storage devices are commonly found in homes and small businesses. They basically let you attach storage and then you can access them over the network. So they tend to be loaded with services and they tend to be easier to use. During the course of looking at this device, we found lots of different vulnerabilities in the web application and some of the services. We've got cross-site scripting, command injection, SQL injection, all kinds of good stuff. The results of these vulnerabilities are important because they let unauthenticated attackers gain complete access to the device. From there, they've also got a foothold into your network now, and they can begin attacking devices on your local network. So today we're going to go ahead and start taking a look at some devices. My screen locked. Okay. So one of the things I like to do when we get started is just take a look at the manufacturer's website. So here we are at TerraMaster.com. First thing you'll notice is that a lot of the images on the front are broken. That's always a good start. Down here we can see what the device actually looks like. It's this nice little white unassuming box. It's a 2-bay NAS. It's got a nice quad-core Intel Celeron with 4 gigabytes of RAM, so it's not too much of a slouch there. But that kind of thing. So with that out of the way, here's the login page for the web application. When you set this thing up, you get a admin user account and you set a password for it. So I've already went ahead and done the initial setup. So you can log in and you get this sort of desktop looking thing. Has like shortcuts here and you can select a few of them. There's a system information thing under me, but that's okay. So one of the most important things a NAS will do is file management. So we have this thing, and apparently I'm not allowed to see my home folder, so that's interesting. I haven't figured that quite out yet. But we have like folders in here and upload files, all that good stuff. We have a control panel where we can manage users, create groups. We can enable different features and things like that. Here we can confirm some of their specs that we saw earlier and all that. So we're clicking around, and it's always fun to just start things and see some of my payloads in here already, but how about we try creating a user? When we're testing these embedded devices, we tend to assume that anything you do in the web application might be passed to some sort of command line utility, a shell script, or a CGI binary or something like that. And in this case, creating a user is something that you definitely want to see, or you're expecting to see done at the command line level. So instead of something like admin, we could do something like new user, and we'll give it a password. And they don't need SSH, and they don't need a quota, kind of thing. So we'll click through that, and we've got a new user. So while I've been clicking through here, I'm also proxying my traffic using Burp Suite, and this is a web proxy that lets you basically store and look at the requests your browser makes, and you can also modify them on the fly or after the fact. So if we look a little bit, I believe one of these will be where we created the user. Yeah, this one. So I'm going to send this to my repeater so I can get a better look at it. Oh boy. Burp is notoriously unreliable. We can see it messing up. All right, let me try restarting this. The life of a security hacker. All right, let's try that again. All right, so here's this request we used earlier. It's a fairly basic looking HTTP request. It's a post. Looks like we have a session cookie. We're using this handle process add user, which is expected. We have this username that I provided it, and this very secure password. So we can imagine what this is doing on the command line might look something like, I don't know, user add, and with whatever the username is that I use, new user, something like that. So let's try and insert some shell meta characters. And in this instance, we're going to use the backtick characters. And let's just try to do a very simple command injection here. So let's try to create a file. I'm going to URL encode some of the special characters. This is a space. And slash temp. And we'll give it a file name of ISE. And we're going to close the backticks. And this looks good. Let's go ahead and fire this off. And it says operation successful. So in theory, if this attack worked, we just created a file in /temp called ISE. We can verify this by SSHing into the device. And this is a service that's enabled by default on this device, and we can access it with the admin account. Here's its IP address, and in this case, it's listening on port 9022. All right, so we have access to the device. We are the admin user. And let's go ahead and look inside the temporary directory and see if we have a file called ISE, and we do right here. So this proves that we were able to create a file using this request over here to create a new user. So if you have a username and you create it and it has these backtick characters or maybe even a $sign notation, which we can get into later, you can essentially run commands. So we made a file in /temp. But it gets better than that, because as we can see, it looks like this file was created as the root user. So whatever process was creating this user runs as root. So now we have a root command injection here. Now this one required authentication. We need this cookie here. If I change this to something bad, this probably won't work. -1. So that's interesting, but it requires you to essentially have admin access to the device already, and at that point you've got other problems. So let's head back to the web application and see what else we can look at. So we're going to stick with this control panel, and let's check out shared folders. Firefox is being helpful. Very helpful. Oh, I have to turn intercept off. That's my biggest mistake all the time. All right, so we're back to our shared folders. And we can create shared folders, and these are folders that are essentially shared. I believe you can control which users get access to them, things like that. So let's call it, I don't know, folder new, very original. And we don't need a description, it won't be hidden. Let's give everyone full access to it. All right, so there we go. And we can head back to Burp, and again, we're gonna find the request that was responsible for creating this folder. And this looks like it. We'll send it back to repeater. And we will head there. So we can see it's a similar looking request. It's again going to ajaxdata.php. We've got add folder, we have the folder name I specified, I didn't give it a description, and all these other things look fairly default. For this one, we're going to try something a little different. Instead of doing a command injection attack, let's try to get some cross-site scripting. The cross-site scripting is when we can inject HTML entities and basically execute JavaScript on the web page. So we're going to give it something like image. We're going to insert an image tag with the source of some file that we know doesn't exist on the web server. So let's just guess that A doesn't exist. And when this image fails to load, we're going to do an alert box. And we need to URL encode this. Go. Operation successful. All right. Refresh. Oh, look, we just got cross-site scripted. There's that alert one that I just typed into our work request down here. So now we can execute JavaScript on the page. So why is this interesting? Well, what if instead of alerting one, I did something like alert document.cookie. Now when I refresh the list of shared folders, I can see my cookies. We're on page 1, I am admin, and here is my session cookie. So this becomes problematic if you have, say, a rogue administrator for this TerraMaster device, and they want to collect everyone's session cookies. They can then write JavaScript that'll send these to their own controlled servers, or they could send it somewhere else where they can retrieve these cookies later, and then they can effectively control your session with these. So this is actually kind of two issues here. We have cross-site scripting, and then we know that the cookies are being set without the HTTP only flag, which would prohibit JavaScript from accessing the cookies values. You can see the result of the broken image here. What else do we got? This is a fun device, and I found that almost everything was vulnerable to something. Here we go again. This one's a little misleading because it's also got SSH in here, but we can see again by default we've got Telnet and SSH on. It's got a web server that you can upload files to and serve. It's a fun thing. So I could continue poking around and seeing what happens. But this might get tedious. There might be dozens of vulnerabilities. And what if I want to find some quickly? Well, to do that, we would probably want to look at the application source code. And this would let us look for problematic functions like something that calls shell commands, or we could see where authentication isn't being checked. And if we look up here in the URL, we see that it's index.php, and I hinted to this earlier, but we found ajaxdata.php here. So we got a pretty good chance that this is a PHP application. So what we're going to do is we're going to head back to our SSH session, and we're going to try and find those PHP files. So I'm going to use a find command. And this will look for anything that ends in PHP. So we're getting a whole lot of permission errors, but there were some results up at top. Looks like we've got some in user share MySQL and user dub. So it looks like /user/www is the primary directory here though. So let's go ahead and look into user www. You can see what looks like a web root here. You have an index.php. So let's try to check out this file. That looks right. Another index.php. Oh, that's interesting. That doesn't look like a PHP file. That looks like binary garbage. We have file on this device. Ew, it says it's data. Oh, this isn't PHP. What else do we have? How about upload.php? Same thing, it's saying it's data. Well, I guess we can't read the source code. Or can we? We're probably not going to do much while this is all on the device here. So let's go ahead and let's tar up the source code here. I'm just going to do the whole directory. We will call this code.tar. So now I have this nice tarball here. And so let's go ahead and get my IP address. I am this guy. I'm going to set up a netcat listener, which will allow me to quickly transfer files here. And I'm going to netcat the file over from here. Give that a second to go. All right. So let's extract this directory or this tarball. And it looks like we got our files here. So now we can look at them a little closer. It's this Ajax data PHP file we were looking at before. And again, it's telling me it's binary file. Okay, so nothing's changed, which is what we expect. So why on earth is this the case? Why are they encrypting their PHP files? Is this some sort of obfuscation, or I guess that's all I can think of. But so how might we decrypt these files? Because at some point they have to be decrypted. PHP is a scripting language. It relies on plain text files that just essentially list what the program is going to do. So something that might be responsible for decrypting these files is the PHP interpreter itself. So let's head back over to the NAS device and let's find where the PHP interpreter is. So we'll do a which PHP. It looks like it's in user sbin PHP. So again, we're going to send a file to my computer. All right. And I have the PHP interpreter here. So I'm going to use a disassembler to open up the executable, and we're going to see what we can find. I'm going to use Binary Ninja, but there are other tools available for this. think I can make this a little. So what a tool like Binary Ninja does is it opens up the binary. It's going to find all the function names and any hard-coded strings that might be in it. As you can see here, it's doing a whole bunch of analyzing on this file and see what it can tell us. I'll open up another window here so I can look at some stuff while it's going. So to recap the problem, we have the .php files. They're encrypted, and we believe they may be decrypted by the PHP binary. Since they're files on a file system that are being decrypted, we can take a pretty decent guess that it's going to be a symmetric encryption where we have one shared key. And the key must be stored somewhere on the device because otherwise it couldn't start itself up. So we're going to see if that key is within the PHP binary. So we're going to head back into Binary Ninja. We're going to go over here and we're just going to search for something that might be related to symmetric encryption. Something like AES is a good guess. So we have a few results here. So these look pretty generic, but screw AES seems interesting to me. So let's click on screw AES. So here we can see a function, and if you're not familiar with assembly, that's okay. No one really wants to look at this very long. Some people do, I guess. I certainly don't. But we can see that screw AES is called in this function here. So let's check this function out. Here we can see it's being called. What else happens here? This is where the function starts. And we have this interesting looking string sitting over here. If I zoom out, I think it's the only interesting looking string. So we have an interesting string that may later be passed to this AES function. Is this our key? Maybe it is. It's a pretty good guess. Right under it, we see MD5 being called, and if I remember my assembly instructions, it looks like this is the parameter being called and being passed to MD5. So it looks like this might be the pre-key, if you will, and then the actual key would be its MD5 value of it. Don't know if you can copy out of here. Yeah, we can type. It's not too. So we've got GH 65 H WS J F3 and GH65 WS L3. Okay, so look good. All right. So this is what we think might be the key. And more specifically, we think that that is the key. This is the MD5 hash of that pre-key, is what I'm going to refer to it as. So we think we have AES encryption being used. We think we have found the key to it. So let's try to decrypt one of these files. To do that kind of thing, we can use OpenSSL, which has a nice command line interface for just doing generic encryption and decryption. And I have a saved command because it's a little long. All right. So first thing we need to do is we need to convert this pre-key into the MD5 hash, and then we need to convert it into a hexadecimal encoding. This will prepare it for use with OpenSSL. So we have this nice one-liner here that Jacob Thompson, a principal security analyst here, helped me write. This will echo the key. It will take the MD5 sum of it, and we're going to get rid of that pesky dash and all of these trailing new lines, and then finally format it as hex and get rid of some more new lines. So we end up with this, and it's collisioned a little bit with my prompt here, but that's it. So then we can use this next command will let us use OpenSSL in conjunction with our new key and try to decrypt an index.php file. And this is going to be user www, and let's do 3.0/index.php. So this is better than it was before, but it looks like the first block didn't quite get decrypted right. Something you'll notice is we're using an IV of 0. We don't really know what the initialization vector is for their AES. We're just taking a guess. But we do get most of the file back. Let's try another example. Here we go. We've got most of the file. We have some characters. And we could go on with this process for quite some time until we finally decrypt all the files, but luckily I have a nice find command which will execute our decryption script or decryption command. And what this will do is create a new file that ends in .dec.php, and this will have all the decrypted PHP files. So we can run this, and we're going to want to change directories first. All right, then we can call this, and it's going to go for a while. There are lots of PHP files. Okay, so now we're done. We have all of our decrypted .php files in here. Let's do CPU. So it still thinks it's a binary file because of the first line doesn't get decrypted quite correctly, but we do have the files here decrypted. So we have extracted the key from the PHP binary. We've decrypted all of the .php files in here. And now we have the application source code. So now we know how the application itself is running, essentially. We can review all of this and figure out what it's doing. There's a whole lot of PHP files here. I don't really want to do that. So what I'm going to do is I'm going to look for problematic functions that they might be using. So this can be pretty easy. We can just use a recursive grep, and we're going to search for something like exec and an open parenthesis. Exec is how PHP can call system commands. Oh boy, we have a lot of results. How many results? We have 761 instances of the exec function being called. Now, surely not all of these are vulnerable, but probably a lot of them are. So we have a lot of results here, guys. This looks awful. All right. I happen to know that there is a file here called plugs PHP. and it might not show up in there, but I assure you it's there. So maybe. Just a second. So there's a vulnerable file that I've determined ahead of time, and I'm having some trouble finding it. Not really sure why exactly. This is one of the hazards of doing this live. Let's see if it exists on them, because it was there earlier. Interesting. All right, well, I guess we'll have to move on from that because that doesn't seem to be working very well today. But we can head back to our source code because there are still how many hundreds of functions here calling exec. So we don't want to find any 0 days today. So I'm going to take a look at something. Does this include? Let's head back to that Ajax data function that we've been looking at, or this Ajax data.php file. All right. So this is the Ajax data.php. This is the file that we've been accessing when we have been creating these users. We've already gotten cross-site scripting here and command injection. So we're pretty sure we can get something else in here if we look. See, Here's the plugs. I assure you plugs is in here somewhere. I don't know where it's at though. No. All right. I might have to cheat a little. We're gonna have to check out. Maybe not. That's probably. I was in the wrong file. Okay. Still in the wrong file. All right, here we go. Logtable.php. This is the file that I was looking for. I know I wanted this one because it uses this plugs.php, which is eluding me for some reason. But here we can see the top is mangled, of course, but we can see that the very first thing it does is it sets this variable called data, and what it does is it just sets it to whatever is in the post body of the request. So we know that this is a PHP file that is going to receive post requests, and post requests are going to have post parameters. So we can see that it's just looking through post data, and looks like there's going to be a parameter called tab, and it might be sys event. Do some stuff based on that. We have some more. Looks like it'll look for tab as online table. And way at the bottom, we have plugs. And we've got, we'll see if tab is equal to get total. Now, I would really like to show you guys this file. For the life of me, I cannot see. Oh, there it is. Plugs.class. Okay. All right. That was fun. That was fun, guys. All right. There we go. So here's this plugs class I've been alluding to, and I'm sorry I'm jumping all over the place, but this is just. Let's try to find log total. There it is, log total. Have I been searching for log table? I think I have been. All right. That aside, take good notes, everyone. That aside, we have this log total function. At this point, maybe it'd be better to go way back. Show our initial grep for exec. Then we can look for log table, no, log total. There we go again. Still not going to work. All right, whatever. I don't care. Here we go. So back to log total. And as you can see, that's the problem. It's got an underscore in front of exec. All right, that's not important. So we know that it's calling exec here. We have this function called log total, and it's going to receive a parameter called table, and it's going to receive a parameter called type. It's doing some stuff. It looks like it's doing something with SQL. We can see a SQL query being built here, and see table and type are being passed in based on whether or not type exists or not. And this is just reeking of classic SQL injection because it looks like they're just concatenating in these table and type parameters. So we've got this mysterious log total function, and it's building a SQL command, SQL query from possibly user input. See, it's table and type. And as we saw earlier, log table, that it looks like the log total function is being called with table and the event parameters from the post data. Again, data was the post data. So it looks like user input is being passed directly into this SQL string. Remember, we have data just grabbing the post parameters, and it looks like they're being used down here if the tab parameter is get total. Two things. We did not notice any sort of check for authentication. Nowhere in between here does it look for a cookie, checks to make sure it's valid, any of that. That doesn't seem to exist. And the second thing is right here, it's just throwing the values into this log total function. And then when they're used here, there doesn't appear to be any sort of sanitization occurring. So we've definitely got the makings of SQL injection here. And ordinarily, it'd be fun to just try and build a SQL injection attack, but it gets a little more interesting to me personally when we come down here and we notice how they're executing this SQL command. What it looks like they're doing is they are calling the SQLite 3 binary on the operating system, and they're giving it the SQL command as a command line argument. So we have this interesting injection point here where we've got an endpoint vulnerable to both SQL injection and command injection. And in this case, we're going to look at the command injection because it's a lot easier to exploit. So it looks like all we need to do is find a post request that goes to logtable.php. We need to make sure we send it a post request. We need to send it a parameter called tab. We want this to be get total. And we want to send a parameter called table and a parameter called event. And in one of those two, maybe both, we'll stick our command injection payload. So get another terminal open here. We will grab the next command I have saved. Eventually. All right, yeah, it's the very last one. So here we've got a curl command, and curl is just a very nice way to send HTTP requests from the command line. And we are going to basically make a post request. And here, as I said, we've got our parameters here for the post request. We have tab. We're going to set to get total. Sorry. We have the table parameter, and we're just going to give it some arbitrary value. We're not sure it even matters, and we're going to use my table. We're going to use event for our injection point. And here I have some very nicely encoded data, which hopefully some of this is just jumping out to you. We have telnet D here, and what this is going to do, and I can try to translate this here. It'll look like user sbin telnet D and -L bin sh HP 1, 2, 3, 4, 5. So what this does is it starts a telnet listener on port 1, 2, 3, 4, 5. And in this case, as soon as you connect to this telnet port, you're going to get a shell. And what kind of shell? We're going to find out. So let's run this curl command. And let me make sure the IP address is correct. Oh boy. All right, let's make sure this IP address is correct. Web application runs on port 8181. Oh, it's on HTTPS. All right, we got a 200 OK. Maybe it worked. Let's use nmap to see if that port opened up on the server. To do that, we're going to use nmap, and we're going to just only look for port 12345, and this will be on 192.168.1.47. And it looks like it's open. The service isn't going to be right because I didn't tell it to do a full scan, but it looks like this port's open. So let's try to just connect to this with telnet 192.168.1.7. And it needs the port, I think for telnet you just do 5. And hey, it looks like we got a shell, and we got a root shell at that. So let's let's do a recap here. We've found this endpoint by looking through the decrypted PHP files. We figured out that it didn't require authentication. It just blindly took user parameters from a post request. And you can do command injection or SQL injection, which I'm not going to go through today. But so again, we have this unauthenticated request, meaning anyone that can access this TerraMaster device could potentially make this request and then start a telnet listener, run commands, do whatever. When you have root control over a device like this, the possibilities are not limitless, but close to it. You can exfiltrate all the data off of the device, assuming it's not encrypted by the user or something like that. So you could steal all those photos or whatever might be stored on here. Business data might be on it, depending on the setting of the device. Perhaps more importantly, you've now got a foothold into the local network of whoever owns this thing, which you can then use to pivot to other devices and do further damage. And that's really it. You're one curl command away from getting a root shell on this device. And all you need is an IP address. And I'll leave that as an exercise to the viewers, but that's not terribly difficult to obtain. So that's about all I have for you today. But we found lots of issues in this. We've got blog posts being posted. There's already one up going through some of the stuff I did today. We've got another one coming up soon that'll have the other issues we found. So stay tuned for that, and thanks for watching, guys.